Here's a practical guide on how to build an online bank/digital banking system inspired by the online bank model, covering the main software programs, architecture, features, tech choices, regulatory needs, and launch steps. Before any coding, focus on bank strategy and compliance. First, regulatory and licensing. Get a banking license or partner with a licensed bank, implementing KYC/AML checks and secure digital identity and verification. Second, security and privacy. Your system must meet ISO/PCI DSS security standards with strong data encryption, multi-factor authentication, and biometric logins. Cloud security and disaster recovery plans are essential as online bank migrated to the cloud to ensure continuity under extreme conditions and secure operations at scale. Next, the core architecture of a digital bank. Online Bank moved most of its core systems and client data to the cloud for scalability, resilience, and easier deployment of new services. You'll typically build a core banking system, the heart of your bank, managing account balances, ledgers, and transactions. Common core banking platforms include Temenos T24, Mambu, Fineract, and Backbase. An API layer allows all services to communicate through REST/GraphQL APIs, supporting third-party integrations for open banking. Mobile and web apps call these APIs to display user data. Online Bank Program provides both web and mobile access to accounts, payments, transfers, loans, and business services. Data and analytics are crucial for real-time insights and machine learning, used for personalized offers and fraud detection, as Online Bank already uses AI and ML in services like loyalty programs. Security modules handle authentication, device binding, biometric checks, and anomaly detection for fraud prevention. 4 core online banking features. To mirror Online Bank's experience, you'll want user account capabilities like sign-up, balance views, transfers, and bill payments. Online Bank's simplified online account opening, allowing entrepreneurs to open a business account in about 5 minutes. Additional banking services include card issuance, deposit operations, business dashboards, and electronic invoicing. Online Bank Program for Business includes value-added tools like digital signatures and e-reporting for entrepreneurs. Extras and ecosystem features include cashback and loyalty programs, free zero-rated data access for banking, and integrated services like payments and remittances. 4 technology stack recommendations. Consider backend with Java/Spring Boot or .NET Core, frontend with React or Flutter, and REST plus GraphQL for APIs. Databases like PostgreSQL or MS SQL, messaging with Kafka, and cloud platforms like AWS, GCP, or Azure are key. Mobile Auth uses OAuth 2 and biometric SDKs, monitoring with Prometheus, and security with WAF and HSM for key management. Development and deployment phases begin with Phase 1, MVP Online Bank, focusing on data models, core banking API, secure authentication, web portal, mobile app, and compliance workflows. Phase 2, Scale and Integrations, adds open APIs, digital signatures, value-added services, and AI or ML features for personalization. Online Bank's cloud migration allowed faster feature deployment and resilience even under external stress. Security, resilience, and DevOps are critical. For security, conduct penetration testing, ensure end-to-end TLS encryption, and regular audits. High availability requires microservices, containers like Kubernetes, and auto-scaling. Monitoring involves real-time logs, alerts, and trace analytics. Testing and go-live includes functional, integration, load, stress, and compliance testing, followed by a beta user rollout. Continuous improvement tracks metrics like active users, transaction success rates, customer satisfaction, and fraud metrics, iterating UI/UX based on feedback. Now, a hands-on, step-by-step tutorial for 2 core features: secure user login and payments/transfers API, using an enterprise stack like ASP.NET Core, JWT, and MS SQL. For user login, the architecture involves the client posting to the auth service, which uses the user DB to return a JWT access token and refresh token. Later, you can add SMS/push/OTP and device binding, as Privat Bank uses strong MFA. The database schema for users includes ID, email, password hash, is active, and created at. The refresh tokens table includes ID, user ID, token, expires at, and is revoked with a foreign key to users. Password hashing uses bcrypt.net to hash and verify passwords. Never store plain passwords, an online bank level rule. The login request DTO is a simple record with email and password. The JWT service generates a token using claims, a symmetric security key, and signing credentials, setting an expiration of 15 minutes. The login endpoint handles the post request, verifies the user, and returns an access token. This is exactly how banking APIs start. Secure API access is achieved with the attribute. Now, the heart of online banking, payments/transfers API. The payments architecture involves the client posting a transfer request, followed by validation, transaction, ledger update, and audit log. Money movement must be atomic. The accounts table includes ID, user ID, balance, and currency. The transactions table includes ID, from account ID to account ID, amount, created at, and status. The transfer request DTO contains from account ID to account ID and amount. The payments API handles the transfer transactionally, finding accounts, checking funds, updating balances, adding a transaction record, and committing the changes. This is bank-grade atomic transfer logic. Critical banking add-ons include idempotency keys, fraud checks, async event queues, audit logs, limits, and rollback logic. Finally, how online bank-style systems evolve, from MVP with login and transfers, to cards and IBAN, then business accounts, AI fraud detection, and open banking APIs.